All right, this is the video that you are doing for homework tonight, which is Wednesday, March 4th, and you got this worksheet in class today. If for some reason you didn't get the worksheet, you can just write this on a separate sheet of paper. So hopefully this won't take too long. We'll go through it kind of quickly, so if you need to pause and stop it somewhere, you're welcome to do that. So for a brief review, at the top of your paper it says I equals blank. So I is equal to the square root of -1, if you remember correctly. We haven't used that as much in the last week or so, that should be review. So if we're going to simplify something like the square root of 25, I would separate it into the square root of 25 and the square root of -1. So I know that the square root of 25 is 5. Let me put my plus or minus out front. And the square root of -1 is I. So our answer is -5i. So for this next one, the square root of -7 would be a little bit different because I can't take the square root of -7. It's not a perfect square, so I would just leave this as the square root of 7 times I. Notice I'm kind of closing the end of my square root sign so that it's really clear that I should be outside of the square root sign because we've already taken the square root of -1 and our answer is I, so it's not inside of a square root sign. So you can do this in the same way that we've simplified other radicals. So we've got the square root of 4 times the square root of 3, if we were simplifying 12, and then we're just adding in that -1. So this is 2 square root of 3 times I. And then the same thing for the square root of 150, so that would be 25 times 6 times the square root of -1. So 5 square root 6 I. Put my plus or minus out there. So that's just kind of a quick review. So then it says a complex number is a number of the form a plus bi, where a and b are both real numbers, and I is the square root of -1. So each complex number has two parts, the real part a and the imaginary part b. So we're going to just identify the real and imaginary parts in each of the following. So this is the real part, 5. This is the imaginary part, 8. So we just say a is 5, b is 8, because it's what's being multiplied by -1. So -2 is a little bit, number 2 is a little bit different because it has a denominator. So I'm just going to separate this into two terms. This is 5 halves plus 3 halves I, or 3i over 2. So our real part is here. A is 5 halves. And our imaginary part is here. B is 3 halves. And then number 3 is still a little bit different. So we just have one term here, the square root of 10 and I times I. We're not adding or subtracting anything. So you can kind of think about it as 0 plus that, in which case our A value is 0. And our B value is whatever is being multiplied by I. So in this case, B is the square root of 10. So we can add and subtract complex numbers. It's going to work in the exact same way as adding and subtracting like terms. So we can't add and subtract if they're not like terms. So i's go together, and constants, or things without i's, the real component, those also go together. So for example, we've got our real components, 5 and -2, which gives us 3. We've got our imaginary components, 4i and 3i, so that gives us a positive 7i, which would be our answer there, 3 plus 7i. So same thing with the next two. If you want to pause this video for a second and try those, and then unpause it so you can check them that you got them correct. Now would be a good time to do this. Pretty straightforward. So 6 plus 4 is 10. 5i minus 7i, or plus -7i, is a -2i. So that's your answer. Last one, -5. And then here we're subtracting, so you're going to need to distribute that negative just like we would any other way. So that would be a plus 3 and a plus I. So our real components are this -5, like I underlined before, and 3. So -5 plus 3 gives us a -2. And a 3i and a 1i gives us 4i. So that's our answer. So if you turn over to the back side, multiplying complex numbers is just a little bit different than what we've done before, but for the most part you should be able to follow it pretty easily if you understand how to multiply binomials, which I know you all do. So 2 plus 3i, 4 minus 5i, just like any other thing that we would multiply. If I put them in the opposite order, that would have been fine. So I've got an 8 here, I've got a 12i here, I've got a negative 10i here, and I've got a negative 15i squared. So here's the thing about I squares, and I'm just going to make a little note. So we'll kind of scooch this over for a second. If I is equal to the square root of negative 1, then if I square I, that means I'm squaring the square root of negative 1. So when we square the square root of something, the square root and the square cancel out. So I squared is actually negative 1. And that's a little confusing because if a number is imaginary, then it seems like if we square it, it should also be imaginary. But in this case, if we square I, we actually get a real number, which is why this is so helpful for our unit on polynomials. So I'm going to go back to what we just did. Whoops. Okay. It's a little bit bigger. So we've got 8, and then this negative 15i squared. This will be negative 15 times negative 1, which is actually a positive 15. So we're going to add together 8 and positive 15 to get 23. And then my like terms here add to 2i. So I'm going to actually zoom in a little bit more so that well, you know what? I'm just going to go to another page. Let's do that. So for your next problem, number 1, you'll make another box just like you did before. So 6 plus 5i, and then we've got 4 minus 7i, so 26, oh, it's not 26, 24. 24. We've got 20i, we've got negative 42i, and we've got negative 35i squared. So negative 35i squared is actually negative 35 times negative 1 because I squared is negative 1. So that's actually a positive 35. So we're going to add 35 and 24 to get 59. And then these guys are like terms. So negative 42i plus 20i is negative 22i. And then number 2, you can do the same thing. If you want to pause this and try it on your own and then come back, be a good idea right now. So 2 minus 3i and 3 minus 2i. We've got 6, negative 9i, negative 4i, and 6i squared. And this is a positive 6i squared, so this time I'm going to multiply 6 times negative 1. I'm going to get negative 6. So in this case, 6 and negative 6 are actually going to cancel out, so I won't have a real component to this answer. And then negative 4i and negative 9i gives me negative 13i, and that's my answer. All right, so the next section is on complex conjugate. So the complex conjugate of a number, it says a plus bi is defined as a minus bi. So for example, the complex conjugate of 2 plus 3i is 2 minus 3i. So the important part to remember here is if you have a plus bi and you're finding the complex conjugate, you're only taking the opposite of the imaginary term. So a minus bi. So the a value, notice, stays the same. We're not changing the real component. So it can also be backwards. So if I started with a minus bi, then I'm just going to take the opposite of that component, and I'm going to leave a by itself, so a plus bi. So a plus bi and a minus bi, they're called complex conjugates, and they're going to be really important for polynomials shortly, but it's important that you just understand how they work and how they multiply together. So for number 1, the complex conjugate to 2 plus 9i would be 2 minus 9i. And something kind of interesting happens when we multiply them together. So if I multiply 2 minus 9i, 2 plus 9i, I get 4 minus 18i plus 18i minus 81i squared. So this minus 81i squared becomes plus 81. And these are going to cancel out in the same way our difference of squares. It's almost the exact same concept as the difference of squares. So I'm going to add my two like terms. So I've got positive 81 and positive 4. So this answer is 85. So when the question asks you on your paper, it says what happens when a complex number is multiplied by its complex conjugate, the answer there is that the product is a real number. So notice we don't have an imaginary component to this number. And the same thing's going to happen with our next problem. So the complex conjugate, this is a little confusing because you're tempted to just make this a positive 5, but it's still negative 5. So we're keeping a by itself. So negative 5 minus 2i. And then I'm just going to multiply them together. So negative 5 plus 2i, negative 5 minus 2i, 25, negative 10i, 10i, and negative 4i squared. So these guys are going to cancel out. This becomes a positive 4. So if I add my 25 and my positive 4, my answer is 29. So again, it's a real number. So you've got a little box to the side. It says, since negative 1, the square root of negative 1 is I, the powers of I can be evaluated as follows. So it might just be helpful to kind of look through these for a second because we will use them later. So I to the first power is just I, or the square root of negative 1. And so I squared, we've already talked about why that's negative 1. So I to the third power is actually the same as I squared times I. And I know that I squared, I'll use yellow, I know that I squared is actually negative 1. So this is actually negative 1 times I, or negative I. It's a little confusing. And then we'll just go to I to the fourth. So I squared times I squared is the same as I to the fourth. So I know that this is negative 1, and I also know that this is negative 1. So negative 1 times negative 1 would be a positive 1. So you'll see kind of a pattern take place if you can continue this. So what I would recommend you try is what is I to the fifth and I to the sixth. And you'll see them on your paper, but see if you can kind of figure it out before you get there. And then we'll continue to talk about more complex numbers in class. All right, that's it.